we are gonna discuss what we would solve in this live session and what exactly we are doing in this live session. So, in today's live session, we are gonna solve the problem, the remaining Amazon problems. We solved around 35 problems in these live sessions itself. You can watch these live sessions in your what do you say, my previous lives. And don't worry, this is gonna be super fun. Let's see who has joined us. Oh, it's my old friend Simran. Simran Sari. Um, I think you have attended all of my live streams, so I'm really grateful for the support. And let's keep it light and fun. I know you people get bored easily, but don't worry. We're gonna do everything possible to make this fun, interesting, as well as lively. You know what, this doing a live where I'm solving the problem live actually keeps each and every one of us accountable, and that is the spirit of solving DSA. Doing all that alone feels like hell, but if I share this hell with every one of you, it, it becomes a less daunting. You know what they say, misery really loves company. But don't worry, all we're gonna do is interesting, fun things, nothing boring. Trust me on that. Please trust me on that, because I really need you to trust me on that. So, this was the Amazon interview playlist which we solved up until the 35th problem. But no worries, we're gonna cover up the rest of medium and hard problems. So, this is the Amazon interview list where Amazon interview questions are curated here. The last 6 months interview Amazon questions. So, let's dive into this. I'm gonna pick a medium problem to refresh ourselves and not get bored of it. You know, the problem solving part. So let's go with the part sum 2 problem and see how that goes. You can roast me, you can do anything, just chat. I don't know why people try to remain silent in the live chat. You can ask me anything, I'm gonna answer that to you. So don't get shy and all on me. That doesn't work here. So let's dive into the problem. Part sum 2. Given the root of a binary tree and an integer target sum, return all root to leaf paths where the sum of the node values in the path equals target sum. Each path should be returned as a list of the node values, not node references. So we need to return each path as a list of the node values, not the node references. That means returning the head does not satisfy the condition. So a root to leaf path is a path starting from the root and ending at any leaf node. And a leaf node's definition is a node with no children. So this is the example problem, example test case which we are gonna see, and which will help us understand the problem even better. So let's see what's going on here. So this is our tree with our root as 5, the left child as 4, left subtree first child, and right subtree first child as 8. 4's left subtree is 11, right is null. 11th is 7 and 2, so on. Now our target sum is 22, and we need to um, find all the root to leaf paths where the sum of the node values in the path equals to target sum. So let's see. First of all, we would check for each root to leaf node path. So this is 1, 5 plus 4, 9, plus 11, 20, plus 7, 27, and our target sum is 22. So this is not a valid path. We would go this direction now. 5 plus 4 would be 9, and this is 11 again, so 20, and this is 22. So our target sum is 22, which is being satisfied in this root to leaf path. And same goes for this, from root to the second node to the leaf. So the sum is 8 plus 5 is 13, and 13 plus 13 is 22. So this is also not satisfying. Let's go in the other direction. 8 plus 5 again 13, plus 4 is 17, plus 5 is 22. So this satisfies our target sum. So this would be the second part, which we would return, and the other is 8 plus 4 is 12, plus 5 is 17, plus 1 18. So yet again it doesn't satisfy. Okay, someone was typing something in the chat. Actually, I didn't see it. Okay, so this was the guy. Let's see who they were. Okay, so they are not some. I thought they were some. I don't know what to say. Okay, so trees are way ahead, and we have just started arrays. So this is an Amazon interview live stream. Obviously I'm gonna discuss every topic. So if you have just started arrays, you can solve problems according to your convenience. This is not for you. Thank you. So I would concentrate on what we were doing. You can subscribe to my channel though. I would definitely cover up all the, from the basics, all the arrays and basic hashing questions and different patterns. So watch out for my channel, subscribe from here, and I will definitely cover that up. But right now we are on this trees lesson. So there are two paths whose sum is equal to the target sum, as we saw. Okay, so that text was quite distracting. Sorry guys. So we need to return this path values actually. So one simple brute force method is exactly what I was saying. Like, I don't know what to say. We need to get every root to leaf path and check if the target sum is, if the current sum is equal to the target sum when we are at the leaf node. We can mark all the leaf nodes inside lists or map something, so that when we reach the leaf node, we know that it is a leaf node. or we can just write a function to check if the current node is a leaf node, and if it is, we would check if the current sum we accumulated up until this point is equal to the target sum. If yes, we would not backtrack, just append all the paths we went on from the root to up until the leaf node. But if it is not, we would backtrack and try to find out other values and append that path in our answer as we get it. So let's see our constraints. See, if the target sum is not present inside, we would just return an empty list. So we need to take care of these edge cases very well. I'm gonna give you 5 minutes to discuss the problem, dry run the problem and understand how you can optimize it, or you can also solve this using the what can we say, basic problem. I mean to say brute force approach. You can solve it using the brute force approach, and then we can discuss the optimal approach if you're not getting it. But it's an easy method. I'll tell you that you'll be able to solve it. So it is quite interesting. I'm gonna start the timer, and as soon as we reach the 25 mark, I'm gonna explain it to you guys so that it becomes easier for everyone and we learn something out of this. So let's dive into it. Watch it properly. I'm gonna solve it afterwards, but you need to think on that problem for about at least 5 minutes. Afterwards, I would be definitely ready to solve this problem. And discuss the solution with you guys. Last Christmas, I gave you my heart, but the very next day, I gave it away. Last Christmas, I gave you my heart, but the very next day, I gave it away. Okay, I just murmur some songs while solving it. You guys can also solve simultaneously, and then we will discuss the problem in around 5 minutes. Last Christmas, I gave you my heart. The very next day, I gave it away. I don't know the exact lyrics also. I only know one song. What the hell is wrong with me? Okay, I don't know what. Last Christmas, I gave Give it away. I wanna give my heart to this problem. Let's see. Okay, so Simran is saying that she has solved it using the brute force approach. Great, Simran. You're good at that. You're better at that. So now I would challenge you to solve it using um, using the optimal approach. Come on, Simran. I'm counting on you. You should count on yourself too. Whatever. So let's go to. I would just solve it in another 2 minutes. I would give you 2 more minutes to identify and solve the problem. I know you can do it. My voice is probably annoying, I know that. All those personal comments are welcome. You can comment anything. I don't mind actually. So, it is what it is. I don't mind what you say. You can say literally anything in my live chat. It is uncensored. Yeah, it is. Please, guys, subscribe to this boring channel. I know it is not interesting, but please do it for me. I'm really struggling out to gain an audience, and I'm begging you guys at this point to listen to me. Please, guys, please listen to me. Okay, I'm gonna see what the problem is about. So let's first solve with the DFS approach. With the approach we discussed actually, so that what we discussed becomes clear to you. So first we're gonna start with, if there is no root present, that means the tree is empty. We would just return an empty list. Now, if not, node dot left, that means the left child of the. Okay, what am I doing? Sometimes I get crazy. I would just initialize the result array with this, and then my DFS again with the root dot val. I would return the result afterwards, later on, after that DFS performance. Now let's dive into the DFS, because we are building the function from the start. Let's dive into this now. So we have a node and an array as our two values inside our list, inside our function. So if the node does not exist now, we reach the end of the tree or the leaf node, we would just return from there. No, we reach the node after the leaf node because no node exists, so we just return from there. So if not node dot left, there is no left node of this current node and no right node of this current node. We would return if sum of array is equals to the target sum we would append the result array into our result, and then later on we would return from there. Because this not node dot left and not node not right means it is a leaf node. So these two are our base cases which we needed to handle. Now comes our recursive function. So if node dot left exists, we would just do a DFS on that. Node dot left comma array plus we would add this value node dot left dot value, because our current path would be added to the array which we are currently at. Now we're gonna check for the right child and see what happens. DFS node dot right, and now we would add into the array our value, which is the node right child's value, which would be this node dot right dot val. Now, so we have completed the function. We have done the edge cases so that we are bound to stop this recursion. So, and we have called out the recursive function also. I don't think there would be any error. Now let's check it out and see if, okay, it does not pass some of the test cases. I don't know why. Now let's see what's happening. I think I did something wrong here. I don't know. Okay, let's check it out. Don't stress out. We never need to stress out, because stressing out is what would ruin your experience, and I don't want anybody's experience to get ruined. I don't know why is this happening, but let's figure it out. We are here for that. Okay, so the leaf node, I'm gonna check the sum of the array is equals to the target sum, and then I would append my result. So what it is, okay, this method is not working. I don't know why. My result variable. Okay, I got it. What I need to do is I need to add the what do you say, this value to the node as well. But it's already been added. Okay, let's ask ChatGPT what is wrong with this problem. Okay, we do not need to return early. We need to append every one of those. But we are returning to the let's see now whether this works. I don't know why it's not getting appended. Okay, I don't think I need to go over this. Let's just ask ChatGPT and what. There is something wrong with my code. I'm gonna test it. So if not root, we are returning the empty and we are initializing the result, then doing DFS. Okay, we are returning the result at last, but that is also cool. So there is something wrong with this problem. I'm not getting. Let me try another approach. This one is not working. We would work on it later on. Let's try a different approach. So let's go for an even easier problem. I'll go with an additional variable here itself and then try it out. let's go with